All right, the second lesson is on derivatives of inverses of functions. Let's talk about inverses, okay? We'll say that f and g are inverses if the following thing is true. F of g of x will equal just x, or g of f of x equals x. What does this mean? Well, it's just kind of how we use inverses to solve for x. If I have some function, f of x is equal to 3, and I want to solve to figure out what x is, I'll be able to use the inverse function, taking it on both sides, and I'll get that x will be equal to g of 3. Okay, and that's very interesting, these inverse functions and what's going on here. So if I plug in x into my function, I'll get the y coordinate of 3. But here in this g function, if I plug in x into this g function, I'll get the y coordinate of x. That doesn't really make sense because you don't like x's as y's, but watch how I do it with points. If we have the point, let's look at, we'll have the point 2, 4. Okay? So I would say f of 2 is equal to 4, right? 2 is the x value, 4 is the y value. Well, that means f of 2 equals 4. Well, let's say I wanted to get 2 by itself. I would have to undo what f is doing to 2. I would take g of both sides, and since g and f are inverses, they will undo each other, and I'll get 2 is equal to g of 4. Well, that means the inverse function g, when x is 4, will give me a y of 2. So I'm going to plot the inverse of f, and I'm going to plot g. And if f has the point 2, 4, g will have the point 4, 2. Okay, that means they will both share the point 1, 1. They'll both share the point 0, 0. But if we talk about this point, maybe negative 2, 4 on the graph of f. Let's see, and this is a very important kind of procedure that you will have to do in this lesson. If f of negative 2 is equal to 4, right? Negative 2 squared is 4. Well, let's see the corresponding point. By taking g of both sides, I get f and g undoing each other. Negative 2 is equal to g of 4. That means for the x-coordinate 4, g will have the y-coordinate negative 2. So that means I also have the x-coordinate 4 and the y-coordinate of negative 2. And what we see is that the graph of f, its inverse, is reflected over the y equals x-axis. And this would be the graph of g. Now, g is the inverse of x. Of f. Now, another way you can do inverses is you can say f and f inverse like that, f to the negative first. This is not f to the power of negative 1. This notation is inverse in this situation. And what I can do is I can replace, instead of f of g of x is equal to x, I could say f inverse of f of x. That would just be x. This would undo this, just leave me x, or f of f inverse of x is x. Now, in other classes, we have been kind of trained to find inverses to show that f and g are inverses. And we could find the inverse of f. F of x is equal to x squared. How do we do it? We take y equals x squared. Okay, you will flip-flop your x's and y's, knowing that your inverse function will have the opposite x and y coordinates. If this is an x and this is a y, then this will have the y coordinate as an x, and this will be the x coordinate as a y. So the inverse equation would be x equals y squared. And these are inverses. Okay, and it's really cool if you have a ability to graph, you know, this implicit curve. You could graph y equals x squared and x equals. And you could see those inverses. So here is x squared, here is y squared, x equals y squared, okay? And for any function, let's just take some simple one like, I don't know, let's take some cubic. So x cubed plus 2x plus 1, maybe something like that. Its inverse would be x equals y cubed plus 2y plus 1. Okay, and they're inverses. I'll show you that. X cubed plus 2x plus 1, and then x equals y cubed plus 2y plus 1. There is the x cubed graph, and here is its inverse. Okay? Now, in past classes, you would take an inverse, and you would solve for y. And that way you'd have a function. Y is equal to plus or minus the square root of x. And here would be the positive root x and the negative root x. In this class, we actually don't really care about that. Don't really care about solving for y. You could just say that this is an inverse. And really, in general, in this class, we're not going to have to worry too much about finding inverses. Okay? I'm actually going to skip this section. And we're going to just kind of move on. Okay? If you wanted to find the inverses, you could swap x's and y's and solve for y if you wanted to find the inverse function, or you could just say x equals 3y plus 1. That would be the inverse of this. X equals root 2y minus 3. That would be the inverse. But let's move on to finding the derivative of the inverse to a function. Okay? There are three methods that we can use, and I'm really just going to go straight to the third method, which is the preferred method, which I think is the easiest method to use and the method you actually need to use for AP-style problems when it comes to inverse derivatives. Okay? And it comes from this formula, the inverse derivative formula. So let's say I know what f is, and I want to know a tangent value of g. Let's say I want to know what the slope of the tangent to g is at this location. What is the slope? Okay, well, let's see how I can use my knowledge of f to help me find what the slope of g is. Well, let's start with this fact that if f and g are inverses, this is true. F will undo what g is doing to x and just leave me x. I'm just going to go ahead and take the derivative of these, both sides. Okay, and this is how I'm going to create my formula. So the goal is to find the derivative of g at some x value. All right, so to take the derivative of the left side, I have to use the chain rule. It's the derivative of the outside, leave the inside alone, times the derivative of the inside. And the derivative of the right side is just 1. The derivative of x is 1. Well, I can solve for g prime simply by dividing by f prime of g of x. Okay, this is really interesting. And I'll show you what we can do with this and what this means. This means the derivative of my inverse function, inverse to f. The derivative of my inverse function is just 1 over the derivative of f at the g of x point, or at the y coordinate. Let's see what that means if I went back to my original situation with x squared and its inverse. Let's find g prime at that value 4 that I was looking for. Okay, so let's go g prime at 4. That's what I'm trying to find. Okay, well, let's see. Using this formula, it's equal to 1 over f prime of g of 4. Well, what is g of 4? G of 4, we said the y-coordinate when g is 4 is 2. It's also negative 2, but in this case, we're going to look at this point 2. So I'm going to say that is equal to 1 over f prime of 2. So it turns out, if we go to f prime of 2, this slope here is actually the reciprocal of this slope here. So the derivative of f prime, is 2x. F prime at 2, the slope would be 4. That means this slope right here would be 1/4. Okay? So, sorry for it being crowded. I'll just kind of tell you overall what this means, that the derivative, I'm going to type this in. The derivative of an inverse function at a point is equal to the reciprocal of the derivative of the original function at its corresponding, we'll say flip-flopped xy point. Okay? So if I want to find the derivative of an inverse function, I just need to know the derivative of my original function, and then I will find it at its corresponding point. So that means, and this is kind of important to write down, if I have the slope of the tangent to f, so maybe if I know f has the point 2, 3, and I know f prime of 2 is equal to 5, well, g is going to have the point 3, 2, and f prime of 3, or g prime of 3 would be equal to 1/5. Okay? That's kind of the deal. If I have the point 2, 3, slope of 5, I'll have the point on its inverse, 3, 2. The slope will be 1/5. Okay? Now, it might not make that much sense to you. The key to this lesson, this entire lesson, is just being able to use this. And I'll show you how we're going to use this to answer some problems. Okay? This is the inverse derivative formula. You'll have to either commit this to memory or know the procedure to go from here down here by taking the derivative using the chain rule and then solving for g prime. Okay? So here we go. So we are told f and g are inverses. Find g prime of 3 given that f of 6 is 3. Okay? And we know f is this. So let's find g prime of 3. I know g prime of x, knowing my inverse derivative formula, is equal to 1 over f prime of g of x. Good. Well, I need to find g prime of 3. Well, g prime of 3 is equal to 1 over f prime of g of 3. Okay, well, I'm given the function f. I am not given the function g. Now, what I could do is actually kind of flip-flop x's and y's and go from there and kind of find out what g of 3 is, but it's actually going to be easier for us, and I'm going to show you why. For all AP-style problems, they usually give you a very, very important piece of information. They tell you that, hey, if you plug in 6 into this function, 2 times 6 minus 3, that's 9, square root of 9 is 3, you're going to get the y-coordinate 3. Well, that's going to be helpful. Because if I'm trying to find out g of 3, watch what I can do. Let's just say g of 3 is equal to some missing value. I know that f will undo what g is doing to 3. Okay? So f and g will cancel each other out, and I'll get 3 is equal to f of some value. Well, look at that. F of 6 is equal to 3. That means g of 3 equals 6. All right, well, since I know that piece of information, I know what g of 3 is. It's going to be just 6. Well, now to find the derivative of the inverse to f at 3, I just need to take 1 over the derivative of f at 6. Well, I can find the derivative of f easily. Now, it is a chain, so I have to take the derivative of the outside times the derivative of the inside. The 1/2 and the 2 will cancel. But I can find this value at 6. F prime of 6 would be equal to 1 over the square root of 2 times 6 minus 3. 2 times 6 is 12, minus 3 is 9. Square root of 9 is 3. This will be equal to 1/3. Okay? That's the procedure. That's pretty much the basis of this lesson for these inverse derivatives. Okay? Let me show you a couple more. Another one with a function f. Okay, we are told that f equals 4x squared minus x. We're told that f and g of x equals x. We want to find g prime of 3, given that f of 1 is 3. Okay, this is showing me that g and f are inverses. And I want to find the derivative of the inverse to f at 3. And I'm told this point. This is a very important piece of information that we're given. Okay? Well, I know g prime of 3, just using my formula, will be equal to 1 over the derivative of f kind of at its corresponding point, at its flip-flopped xy. Well, let's figure out what g of 3 is equal to. Well, this is where the piece of information helps us out. So f has the point 1, 3. G is going to have the point 3, 1. You can either just go straight to here, or if you wanted to, you could say, hey, what's g of 3? It's missing a value. Take f of both sides. That means 3 is going to be equal to f of some value. Well, f of 1 is equal to 3. That means g of 3 has to equal 1. So when x is 3, the y is 1. So it turns out it's just 1 over f prime of 1. Well, can I find f prime of 1? Definitely. Here's f. F prime, 8x minus 1. F prime of 1 is going to be 7. Okay, so I get 1/7. And that's my answer. Okay, let's look at your homework. Let's do a homework problem. So your homework is a couple quick, simple problems, and then some problems on inverse trig functions, which we'll talk about. So let's look at 71. And I'm giving you information that an AP question would give you. It says to find g prime of 2 given f of 1 is 2. Okay, so 71 is this. And I know you're probably thinking, why doesn't he do an odd? But don't worry about it. And I don't want you to look at the odd answers to these, because they're going to do things that are confusing to you. They're not going to use the inverse derivative formula. Okay, so I want to find g prime of 2, and I told you in the assignment page that f of 1 is equal to 2. So I'm giving you the point that when you plug in 1, 1 plus 2 minus 1 is 2. And this is important information, of course. So using the inverse derivative formula, g prime of 2 will equal 1 over f prime of g of 2. Well, f has the points 1, 2. That means g is going to have the point 2, 1. The derivative, 2, will be equal to 1 over the derivative at 1. If you want to do it another way, you want to find g of 2. That's equal to some missing value. Take f of both sides, and you get 2 is equal to f of a missing value. What is the missing value? 1. So g of 2 is 1. So I just have to take 1 over f prime of 1. F prime is 3x squared plus 2. F prime of 1 is 3 plus 2, which is 5. So this is 1/5. Easy. Okay? Now let's see what they did in the odds. Oh, they kind of used the inverse derivative formula. They found f prime. They know f of 1 is 2. Okay, so they did it. They did it the same way that I did it, which is good to know. There are other ways to do it as well. Okay, so that will help you for those problems. I gave you all of the information that you need to know so that you're good for that. Now, what we do need to be prepared for our quiz are AP style problems where there's no equation given, and we must use the formula. And it's actually easier than the problems that we just did, because you pretty much have everything that you need here to find this. Now here you're told that G equals F inverse. That means G and F are inverses to each other. You want to find G prime of 2. Well, you have to know the inverse derivative formula, but you guys do know it. It'll be 1 over F prime of G. G of 2, well, I know F has the point 5,2. That means G is going to have the point 2,5. So when I plug in 2 for G, I'll get the y-coordinate 5. I get 1 over F prime of 5. F prime of 5 is -0.5. So I get my answer -2. Okay. Let's do another one just like this. Now you might be asked, what is F inverse prime of 3? And you're given values for F, you're given values for F prime. So it seems very simple. If you're not comfortable with F inverse prime, you can just use G. What's G prime of 3? That way it's easier for you to work with. Well, you say G prime of 3 is equal to 1 over F prime of G of 3. Now you got to figure out what G has a point of, 3 comma what? Well, F, let's see, and I can also go G of 3 is equal to some missing value. That means 3 is equal to F of some missing value. Okay, so what is the point where F has a y-coordinate of 3? I look in my table, and I'm looking for when F has a y-coordinate of 3, which will be the x-coordinate of its inverse. Well, right here I see the point 5, 3. So F has the point 5, 3. That means G will have the point 3, 5. That means G of 3 will equal to 5. F of 5 is equal to 3. So I need to find now 1 over F prime of 5. Find F prime of 5. F prime of 5 is -2. And there's my answer. Okay. There's a table problem. Why don't we do this problem? Let's go ahead and pause the video. You guys do this problem, and then we'll move on and talk about derivatives of inverse trig functions. And here is the answer. G prime of 3 will equal 1 over F prime of G of 3. Let's see. G is going to have the point 3 something. That means F is going to have the point something 3, or G of 3 is equal to some missing value. That means 3 will equal F of the missing value. Well, F of 6 is equal to 3, so it looks like we have the point 6, 3, so G of 3 is 6. So I want to find 1 over F prime of 6. F prime of 6 is -2. There's your answer again. Okay? Very similar type of problem, AP style problem. You'll have these problems on the quiz. But I don't think they're very hard. Okay? We will talk about the derivatives of inverse trig functions. So I'm going to go ahead and just start with the arc sine, arc cosine, and arc tangent. Now, first thing you need to know, and I'm just going to put parentheses instead of a function just so you're not confused, and we've done this before. that arc sine can be written as sine inverse. That's very important to know that in this situation, that is not sine to the negative first. And sine to the negative first is not the same as arc sine. This is the inverse trig function. Okay? This is cos inverse, and this is tan inverse. Okay, and here are the derivatives. So if I took the derivative of all of these are the derivatives. And you actually have to have these committed to memory, and they're kind of tricky. The derivative of arc sine is 1 over 1, the square root of 1 minus the parentheses squared. The derivative of arc cosine is very similar to arc sine. It's negative 1 over the square root of 1 minus the stuff squared. And then the derivative of arc tangent is similar. It's 1 over 1 plus the stuff squared. Okay, no square root. All right, so knowing that, we can take the derivative of stuff like this, arc sine of 2x. Now here we have a composition. So we have the inside and then we have the outside. If I were to take the derivative, I'd take the derivative of the outside. The derivative of the outside is the following. 1 over root 1 minus stuff squared times the derivative of the inside, which is 2. Fill in this stuff. Okay. Here, the derivative of tan inverse of 3x squared. It would be 1 over 1 plus the stuff squared times the derivative of the stuff. Fill in the stuff. Okay, that's it. That's the derivative of the inverse trig functions. I'm going to do one of your homework problems, 51. This is a good problem. You'll see what happens. So the derivative of this, here we go. I'll have a product, f prime g. I'm going to write it as cos inverse plus derivative of g. That would be negative 1 over root 1 minus, in this case it's x squared times 1, so it's just x squared times f. And then minus the derivative of this is the chain, so you have to use the chain rule. And that's what I get. Now this is the correct derivative, this is fine. However, what you'll notice when you start simplifying things is that I got negative x over root 1 minus x squared, and over here, this is a minus. This would cancel with this negative 2, just leaving me a positive x over root 1 minus x squared. And what you'll notice, if you look at the odd numbers, is that those two will cancel, and turns out our derivative is just equal to the inverse of cosine. Okay, so that's it. You're going to have a couple things memorized for your quiz. The derivatives of arc sine, arc cosine, and arc tangent. You'll have to know these. Derivative of arc cosine or cos inverse is that. The derivative of arc tangent is that. And then you'll also have to have the inverse derivative formula memorized, which is developed by just this statement that inverses cancel each other out. The derivative of the inverse will be equal to that. Okay? That's it. I hope you have fun doing the easy homework. The homework is very easy for this lesson. So good luck with it.